Again, welcome. My name is Michael Thomas. I work as a data scientist in the Hartford, Connecticut area. So we're on the other side of the country here, and I'm really excited to be presenting to you all today. We have a Hartford Power BI user group where I first gave this talk a little while back, and Greg and I connected, and he thought that it would be a good idea. It seems like there's some interest maybe for some Power BI folks in the R space to talk about how R and Power BI can come together. So thank you to Greg for asking me to present. I think these meetup groups are an awesome forum for those of us in the data visualization and Microsoft communities. All of us here know how fast everything moves in this space. And the best thing I think any of us can do for ourselves is to come together and share knowledge, learn, and listen. So this is a presentation I was fortunate enough to give at the Power Platform World Tour last year. And was rated, I guess, the second best talk in 2019, going back a couple of years, by the Power Platform user group community. I know Greg tried to get the person who gave the first best rated talk, but unfortunately, you guys are stuck with me for tonight. So as some really brief background on myself, I'm the owner and chief data scientist at Catchbrook Analytics. We're a data science consulting firm specializing in the end-to-end data science lifecycle, from data management to predictive modeling to model deployment and maintenance. And we also do a lot of higher level data strategy work as well to help executives understand how to grow both analytics and data science departments in a sustainable way that impacts their organization positively and aligns with the organization's strategic goals. I'm an RStudio certified educator and developer. I'm very deep in the R community. I think I saw a couple R community folks on here tonight, so great to see you all. You may have heard me on the R Weekly podcast that I co-host, and I'm super passionate about bringing software engineering best practices into statistical modeling and data analysis, as well as building data products that can tangibly improve our clients' businesses. At the last conference that I was at in person, which seems like forever ago, I mentioned to somebody that I was from Connecticut, and they asked me if that was near Ohio. So I figured I would do a better job of putting Connecticut on the map in my presentations from now on. We're fairly close to Boston, which is why I'm representing a nice Boston brewery here, Harpoon, one of my favorites. And my wife and I are expecting our first child in March, which I guess is our second if you're counting Cooper in the picture on the right. So this meetup tonight is a very welcome break from my nightly routine of painting and putting together furniture.
Congratulations.
Thank you very much.
Awesome.
So on to why we are here today. Predictive modeling and its subcategories of machine learning, natural language processing, artificial intelligence. There's some of the hottest topics in all of business these days. And tonight, I'm going to walk you through what's arguably the most important step in building a predictive model, and that's data visualization. And I'm going to do it using two of my favorite tools to do so, Power BI and the open source statistical software called R. So if you ever want to purposely confuse the hell out of yourself, I recommend doing a quick Google search for the relationship between predictive modeling, machine learning, AI, deep learning, and any other buzzwords you can think of. You're probably going to find more conflicting Venn diagrams and concentric circles than you could ever want. And believe it or not, that image on the right is one of the most popular results you'll get when you do that Google search. And talk about an ugly visualization. And I think a lot of this confusion stems from the fact that the technology is advancing faster than the average consumer can keep up with. And marketing material advertising AI probably sells better than those that advertise predictive modeling. But I like to use the latter term because to me, it's sort of this umbrella that covers all of these different methodologies. It's going to always be politically correct, no matter what type of model or algorithms you're using to make your predictions. As to R, that's a programming language that was developed back in the mid-90s, specifically for statisticians. And it gained popularity in the mid-2000s when it started becoming the go-to software for statistics classes in academic settings, largely due to the fact that it's free and it's open source, as opposed to many of the paid closed source statistical software languages that professors were previously having to negotiate their colleges to use. So RStudio is the most popular IDE, we call it an integrated development environment for writing our code in. And in 2015, Microsoft acquired one of the leading firms in the R support and integration space, which is Revolution Analytics. And since then, we've seen R integration capabilities in SQL Server, Azure, Visual Studio, and all sorts of other Microsoft products. So we'll do a quick poll now. Maybe we have some more people on the line. How many folks on the line have ever used or heard of R before? We can do a hand raise. Or I can ask it in the chat. Whatever's easier, Greg.
I think hand raises is pretty easy. Seeing 18 hand raises, 23. We've got a nice little meme in the chat
awesome.
too. Predictive modeling buzzwords. I love that meme.
I think every talk I do, a larger proportion of hands go up as to having heard R. So it's a good sign for those of us in the R community. So, I don't think I have to preach the importance of data visualization to a group of Power BI users, but when it comes to building a model, there's a bunch of reasons why data visualization is a crucial step in the process. A couple of the simplest reasons are identifying outliers. Especially for larger data sets, simple histograms and cumulative distribution plots can spot outliers that you should remove if you want to train an accurate model that you just wouldn't be able to see in the naked eye just scanning over your data. The second reason is that visuals help you to identify relationships, whether those be linear or non-linear relationships. And if you identify a relationship between your target, what you're trying to predict, and an independent variable, one of your predictors, with something like a scatter plot, it can give you a great indication that that variable, that independent predictor variable, should definitely show up in your final model as well. And if it doesn't, you should ask some questions about your model or your algorithm. And lastly, plots can help you check the assumptions that you need to satisfy for modeling algorithms. I'll show one case of this later on, so you don't have to worry about it for right now. But as a quick example, there are at least 4 main statistical assumptions that your data need to satisfy before building just a linear regression model. And if you don't satisfy these assumptions, there's a very high likelihood that your model's forward-looking predictions will be poor over time. So we're going to reference this slide a few times during this presentation to keep track of where we are. I'm going to be jumping between the slideshow, Power BI, and RStudio. But for now, just know that there are 5 basic steps in the model building process. The first one, obviously, is data collection. You have to start with some data that you can use to answer the business question and answer what it is you're trying to predict. The second is data preparation. In the same way that we have to scrub and reshape data that we import into Power BI in order to work with it, we also have to scrub and reshape our data in order for it to be consumable for the model algorithm that we're using. And next, exploratory data analysis, or what I like to call EDA, is the next step. And this is where you learn about your data. You could just simply summarize and filter the data in tables, different ways. You could start plotting some distributions of your numeric variables. You could visualize some frequency counts for your categorical variables. And you can scatter plot variables against each other to identify those relationships that will help you tune your model to be as accurate as you can make it. And once you've done some EDA, you can move on to the model development. And this is where you actually finally run the data through the algorithms to see how well the resulting model fits your data. And that's particularly the data that we trained the model on. And then we also want to see how well the resulting model predicts data it has never seen before. So that's a holdout sample of our original data that we held out over to the side and we didn't tell our model about. so that we could evaluate our model's predictions for that data set against what actually happened in this held out data set. And lastly is model evaluation. So once you've built a few different models and analyzed their results, you want to do a comparative analysis to see which model appears to be the most accurate before you send it to production. You also want to evaluate if your best model is accurate enough for your needs. If it's erring by too much or misclassifying observations too frequently, then you may want to go back to step one, complete the life cycle, and see if there's more data that we can collect that might be predictive. If there's better ways to shape that data, or maybe different algorithms that we need to employ that might fit a model better given what it is we're trying to predict. So these are the 5 steps in that life cycle that we're going to reference throughout this talk. So I'm going to give this talk like we are working on a group project together, and this will be the fun part. We're going to go back in time and travel back to October 1st, 2019. There is no pandemic yet. Conferences and pug meetups are in person, and there were plenty of paper towels on store shelves. And the governor of Connecticut has a project that he needs our help on. The Department of Corrections in Connecticut is working on a staffing and overhead plan throughout the prison system for the next year. And our task is to help the Department of Corrections predict what the monthly prison population will be for the next 12 months so they can figure out how to staff, because they're having some trouble doing that. So let's start at step 1 in those 5 steps, and that is data collection. The governor tells us that they've been collecting daily counts of the prison population for a decade, and that this data set should be a good place to start. So I'm going to jump to our data set that we have here. And we got a nice little CSV file with 2 columns. One is the date, which is the first of the month. This looks like monthly data, and the total prison population in the state. And we have it all the way back from 2008 down to, we've got 143 rows of data monthly down to the 1st of October 2019, which is today. And this is the data that we'll be working with. So now that we have our data, we have to bring it into R and prep it for analysis. And as you know, data prep famously is often the lengthiest process in the entire data science lifecycle. But it's absolutely critical that we are not training our model on bad data, and we're feeding it good data. We're not biasing our model with poor data in our data set. And in our case, we're very lucky. The data is pretty clean so far. It's a pretty simple 2 columns. It doesn't look like there's any missing data. So there's not much data prep that we have to do, except for telling R what kind of file we're working with and what the column type for each column should be. So I'll show how we're going to do this in RStudio. So this is our RStudio environment. On the left side is where we write our code. And when we run our code, up in the top right, we'll see what happens. We'll see the console, the output of that code running. And then in this bottom right-hand pane, any objects or tables that we create will get stored here in the bottom right-hand pane. So the first thing that I'm going to do is bring in that CSV data that's along this path that I just opened our CSV file at. We're going to use this function called read CSV. And we know that there's 2 columns, date and population. And we need to do some formatting and tell R, hey, that first column, we want to read it in as a date, similar to how Power BI automatically tries to guess column types. We're not going to do that. We're going to set those ourselves here. And population needs to come in as a column type of number. And we're going to assign the result of this function, which will be a table or a data frame if you're an R user, to this object called prison data. That's how you have this left arrow here. So we'll run this little code chunk by highlighting it and running it. And we can see that we got a nice table here that looks exactly like what we just saw in Excel, right? It's a 2 column, what we call in R a data frame. You can think of it as a table. And this is what we'll be working with in Power BI as well. So this is where the fun really starts. This is where we move on to exploratory data analysis, that EDA step. And I'm hoping that, like me, you are also visual learners. And when you have a table of data, particularly a long table of data with maybe thousands or millions of rows, you need to visualize it. It's impossible to see trends with the naked eye row by row. And you learn about your data best when you plot it. I see too many people starting out in data science who forget this step. They get their data and they immediately want to shove it into a deep learning model to say that they, did some AI project. And not only could your model be weak, but perhaps more dangerously, you may have missed some critical things the data was telling you that contradict your model results or created some artificial bias in your model that you would have seen if you had done some data viz first and some EDA. So let's try an example of some EDA. And since this step calls for visualization, let's use Power BI. So the first thing that you'll need to do, it's more of a housekeeping technical thing, but in order to work with Power BI, with R in Power BI, excuse me, is you have to open up the options in the file pane, and you have to point it towards your installation of the R software, which you can download online just from a Google search of searching for R statistical programming language. You need to show Power BI where it needs to run any code that you're putting in Power BI, what the engine is and where that engine lives, which is the R software. So you have to point it there. So that's a little bit of a housekeeping item that you have to do first. And once we've done that, we can go into our transform data, or we can do a data source here. And we know that there's a super long list of possible data sources that we can work with in Power BI. And one of those is an R script. So it's literally copying and pasting the code that you would write in R that produces some tables like we just saw. And we can bring those tables that result from running our R scripts into Power BI nicely. So the way that you would do that is you would hit connect, choose R, and then you would copy and paste the script that I have here, just Control A, Control C, and copy and paste that right into Power BI. We've already done this for you, so I can show you what our query editor looks like. So you might recognize these first couple lines here that we just ran, but we bring the whole entire script that we're going to walk through today that produces a few different tables. And when we run this R script as our data source, you can see that we actually get 7 tables. So in that script, we make 7 different tables. And the one that we selected here for this particular data source was the prison table result, a prison data result that we saw here already. And then those 7 other tables we bring in here as these other 6 tables into Power BI. And all you have to do is just click on the particular table to bring that table in. And like we just saw before in the CSV and in RStudio, we have this nice 2-column data set running from the 1st of January 2008 down to today, October 1st, 2019. So we can take a look at this data. Actually, we'll bring in date on the x-axis of just a simple area chart, and we'll bring in population on the y-axis of this chart. And we can see that in our data set, we have this real significant decreasing trend over time. The populations in the Connecticut state prisons is getting smaller. And we can just put a nice table next to this that shows you the exact counts if you wanted to. And one thing that we know as good data scientists is that trends in our data are not good for models. Models need to be told explicitly that there is this trend, that time essentially is a predictor variable in your model. And the way that we go about rectifying this is actually detrending our data. So if we go to our exploratory analysis page, we can again look at this data that we just saw. This is stretched out a little bit, but this is the exact same visual that we just saw. We have population on the y-axis, date on the x-axis here, and we fit a nice little trend line through it so that we can see we have a decreasing trend line. And one way to go about detrending our data is actually to transform this predictor variable or transform our variable population some way to get this trend out of it. And one way to do that is actually to difference each observation. So that's, if we look at our first observation, we have 19,400 and change, and then our second observation is 19,800 and change. So we would create a new variable that just captures the difference between those two values. So it would be something like 400 would be our first data point, and then the second data point would be the difference between the second and third values, and so on and so forth. So we wrote a little measure to do that pretty quickly for us. We capture the previous month, and we get the population previous by taking the sum of the population at the previous month. And then we do the same thing for the current population, and we subtract the population previous from the population current. So that's just for every observation in our column, we're taking the difference between that observation and the observation that preceded it. So when we do that, we can plot this new variable, and this is that population diff variable, and we can see that we got rid of that trend almost completely, that we have a pretty horizontal trend line, and our data is fairly centered at 0 here. So this means that our detrending of our data and this transformation worked, and that we can now use this new variable as our variable input into our time series model. And this is something that we would not have seen just by looking at the raw data, and is much more evident by doing this exploratory data analysis in Power BI. And this is one of those assumptions, statistical assumptions, that we need to satisfy to do any forecasting, is making sure that your data is detrended or stationary, is the mathematical term for it. So one more thing that I will show in regards to R, for those who aren't familiar, is that you do have the ability to build a R script visual. So, we showed by running some R code that we were able to get a table produced out of that. Other ways, other things that R can do when you run some particular code is it can output a visual. And Power BI has the ability for you to actually write some R code. If you click on the R script visual, using the data that you've already brought in, you can bring your field in here. So I brought in population when I clicked on this R script visual, and Power BI under the hood says, okay, we're going to pass that to you in R. You're going to now call this your data set. So we have data set, the population variable that we brought in, and I can make this histogram using the hist function in R. I can set what I want the title of the x-axis to be, what I want the title of the whole chart to be, the color that I want the bars to be, and the breaks that I want. How many breaks? There's 30 different bars here in my histogram. So I can do that. I can run this code here up in the top right of this little panel, and it will output for us a nice histogram visual. Again, this is a static visualization. Power BI consumes this basically just like it's an image file. So there's not any pointing and clicking or hovering that you can necessarily do with this. It does have the ability to use filters that you might put in to Power BI. So if I wanted to put a slicer in on date, I believe that I could change this date and this visual would be reactive, which is nice. But again, you don't have any reactivity that could go from the visual by clicking on a bar in the visual to the other chart, because this is sort of like a static image. But R does have the ability to create some visuals that aren't necessarily native to Power BI. So you do have the ability to leverage some of the graphical capabilities of R.
That's pretty interesting, because I don't remember slicers working, so that must have been newer, or at least in the past year.
I don't, until I tried it this morning and it worked. So I'm in the same boat as you.
All right, that's amazing. I see Fernando mentioning, our visual is still not responsive for cross filtering. That's actually, yeah. Can you cross filter from a visual to, I guess we can test it, huh?
I mean, in a simple way, we could just build a table, right?
Yeah.
I mean, if we just did it, this would be very crude, but because there'd be only one observation. Getting an ugly little error. So not every bug is.
He's trying to, though. It seems like maybe there's certain ways if you're trying to do the cross filtering, it would work. I mean, you'd think with the slicers, right? And of course,
that it
my
should.
luck, I probably got you to break it, but
I don't know. I think somebody else should do some exploration for us, or I'll work on it in the meantime. It'd be interesting. It's a good question.
we did get some questions previously. If this is a good point to just pause for a minute.
Absolutely.
Yeah, we're getting a question. Do you use RStudio Cloud? And is there a way to get, the RStudio IDE on the cloud kind of linked up with the Power BI service in some way?
So RStudio is rolling out a bunch of different product offerings, right? They're an open source IDE, and R is an open source language, but RStudio is a public benefit corporation that has a bunch of phenomenal software engineers and data scientists working at it. And they are building, pay-for-play tools that you can purchase from them that help kind of ease a lot of the things, mostly around deployment, cloud management, package management, things like that. I think their latest offering, they keep rebranding the names, but the latest one seems to be RStudio Connect and RStudio Workbench. I'm not super familiar with any ways that hosting RStudio in a cloud environment plays nicely with Power BI, to my knowledge. At the end of this presentation, I'm going to talk about a competitor that is actually working with RStudio recently, a Power BI competitor that's starting to go down that route. So maybe we will see some more things come out of the R and the RStudio ecosystem working together a little bit better with Power BI.
Funny enough, Microsoft needs competition to wake up, so that's a great thing to hear.
Absolutely.
Is there any?
Go ahead. Any other questions?
Yeah, so Kiati is asking, can we schedule a refresh now through non-personal gateways, and will that work for these R visuals?
No, that's one of the things that I was going to touch on at the end as well. So we will get there. Thank you for the question.
Gotcha. All right, you're free to go.
Awesome. Okay. So now we are finally on to the part of data science that 10 years ago, it seems so long ago, was labeled data scientist career as the sexiest job of the 21st century. Now we're at the point where now we can run our data through the algorithms that identify the significant patterns and relationships in the data and try to best fit that data with, you guessed it, a model. So first, we have to split the data into train and test sets. And we'll use that train set to actually develop and build our models. And we'll hold out our test set to the side and see how well each of these models predicts against data that it wasn't trained on, that it hasn't seen, and how well each model predicts will compare against each other to tell us which model is best. So we're going to show this in R first, and then we'll show this in Power BI. So we can build our training set of data by taking our prison data table that we have, and we're going to filter it to only observations where the date is less than 2019-1-1. So if you remember, our most recent date month end was, or month beginning, I guess, was 10-1-2019, October 1st. So we're going to only grab observations before 2019. So that'll be through the end of 2018. We're going to turn it into this special time series data frame, and then we're going to take the other data, the data that's greater than or equal 2019-1-1, and we're going to use that as our held out test data set. And we're going to build these two new tables called train and test. Oh, I keep getting that warning message. So we can take a look at our training data set here, this bottom one. It shows us that we have 132 observations or rows of data across two variables or columns. And again, this looks exactly like our original data, except for the fact that it stops at the end of 2018. It doesn't go through 2019. And if we open our test data frame, that is where the rest of the data is. That's where our 10 observations from 2019 are. Those are the ones that we're going to hold out, and we're going to see how well the model forecasts the next 10 months that it wasn't trained on against what actually happened during these 10 months in the test set. Minimum observations totally depends on the algorithm that you're using. It totally depends on the modeling problem, really. Forecasting problems can use less data. If you're doing like a machine learning classification problem, typically more data than a forecasting problem would take. But it's all very dependent on how accurate you're going to be, how noisy your data is. In our case, we have a ton of signal in this data set because there's this really great trend in our raw data. And some features of this data set that actually make it really nice for a forecasting problem. But not every time series is nice and seasonal or has a really nice trend like this. So my consulting answer is it all depends. But very good question. So if we hop into Power BI, we can grab those two tables that we built. One is going to be training data. The other one is going to be test data. And we can plot those together on the same chart. So we'll take our green line, and this will be our training data. And you can see that that runs all the way up to the end of 2018. And this darker colored line is our test data that we have. So this is a nice way to communicate the training and test split that we're doing from a data science-y perspective, making it really consumable for end users who are curious about what we're doing and why we're doing it. So the next thing that we can do is we can run our training data through one algorithm. And the first algorithm we're going to use is called an Arima model. And that's going to be our first model. And Arima stands for Autoregressive Integrated Moving Average. And it's one of the most popular algorithms to use on time series data, especially in the field of economics. After we have this model developed, then we'll run the test data through this built model to see how that model scores data that it wasn't built on, data that it hasn't seen yet. So then we can compare the model's predictions for those last 10 months to what actually happened in the test set for all of 2019 and see how accurate our model is on the unseen data. We'll show that in R first again, and then we'll show it in Power BI. So we'll create first this data frame that kind of holds the last 10 months. This is going to be our back test, actually, that we're going to ask it to predict the next 12 months. That was our original task by the governor. So I'll create this one first quickly, not to backtrack too much, but all this table looks like is all of our original data that we have, plus 12 months of blank values, because that's what we're going to have to fill in later, kind of at the very end of this. But to go back to our model, we're going to first fit our Arima model here, and we're going to train it on that population data that we have. We're going to provide it a few different time series elements, talking about differencing, like we did first order differencing, which is where we're differencing one observation from the previous observation, just that simple subtraction. We're going to give it some information about seasonality and things like that as well. So we'll build our model here, and that model is going to be called Arima Fit. It's not a table, it's a model object, but we can use it to generate predictions. So we're going to ask it to generate the number of rows. We're going to ask it to simulate the number of rows in our test data set, which is 10. And we're going to create this new data set called comparison, where we're going to compare all of our models. So if we run this little snippet of code here, asking it to simulate for our Arima Fit model, the number of simulations, which is 10, which is the length of our test set, we're going to get this new data frame called comparison come back, which is this new table I can pop out over here, which shows our actual data from January 1st, 2019 through October 1st, and then what the predictions from our Arima model were for those 10 months. And we can see that we're a little high here On the first month, we guessed our model thinks that there should be 13,300 in terms of the population number of prisoners, and there was actually 13,228 in terms of the population on 2019-1-1. And then we can do that comparison all the way down, and we see that we actually end a little lower than what actually happened. The model predicts 12,638 inmates at 10-1, and what actually happened was 12,935 inmates. So about 300 more actually happened. And we can bring this up again to translate it a little bit better in Power BI. So the green line is our actual data that we pulled from our prison data table. That was our original table. And then the black line comes from that comparison table that we just made that contains our population and our Arima predictions. And we can see, we can hone in on where those predictions start on the 1st of January 2019 for those 10 months up through October of 2019. And maybe we can even filter our chart a little bit more just to take a look at the differences here between the model's predictions. So it starts out coming in a little low, then it catches pretty close. You know, we're within maybe 40 inmates in May, and we're pretty close as well, within maybe 60 in terms of our predictions versus what actually happened in April. And then we dive off a little bit here. So our model's predicting things to actually decrease quicker than what actually happened. They didn't decrease quite as fast, but we can see that the shape of the two lines is fairly similar. So it captured some of those seasonal components where things dip back up, things dip down in June and things dip back up in July. That was a seasonal component that got captured by our model. So this is a really nice visualization to present, you know, what actually happened versus what our model predicted. And a great use case for Power BI in your data science process. So let's develop one more model. Let's develop a recurrent neural network, which is a little bit more of a fancier sort of AI technique. We're going to take a pretty simple approach where we just have a pretty easy function in R called this NNetAR function, which is an autoregressive. That's what the AR stands for, neural network. And we're, again, going to just use our population data from our training data set. We're not going to show it our test data set. We're going to build our model, which is this object we're going to call RNN fit. And then again, we are going to ask it to simulate using our RNN fit model that we just made for the number of rows in our test data frame, which is 10. So we're going to ask it to simulate the next 10 months again here. And if we run that, we're going to notice that we added that as a new column to our comparison table. So now we have the date, the population, which are our actual values, our model Arima model predictions, and then our recurrent neural network predictions. So we can see, again, we started out predicting a little high, 13.3 again versus 13.2 in terms of what actually happened on January 1st. And then we ended, our models were within 1% of each other in their predictions for October, which was still, you know, a little bit lower than what actually happened. But we can see that we've got some pretty close values here. We're only 14 people off in August, it looks like, when there were 13,033, and we guessed 13,019. We're at 12,940 versus 13,001, which is within 61 people, which is pretty close. So there were some high spots and some low spots. But again, the best way to visualize this is to hop back into Power BI and take a look at a line chart just like we did for our Arima model, but we'll do it for our neural network model here. And our neural network is going to be our red line versus, again, just the same green line, which contains the actuals. And we can see, similar to our Arima, you know, we had a pretty big drop expected. Our model expected a pretty big drop to happen in February, and instead there was an increase in the actual data. So we have a pretty wide gap here, but that gap starts to close down here in April. Down here in April, all the way through very tight in what the actual was versus what our model predicted in August and September. But then it finishes off expecting a really big drop that didn't really happen. Our green line stayed pretty stable. So interesting to be able to compare visually the results of both models, the predictions of both models against our test data set. So this last step in the modeling lifecycle is model evaluation. And that's what I talked about before, where we compare the different challenger models we developed. We developed 2 models just now against the unseen test data in a quantifiable way. So typically the model with the best accuracy is the one that we will use in production. So I'm going to show how we calculate this accuracy quantifiably in R, and then we'll bring this into Power BI. So there's 2 different metrics when you're working with time series data as opposed to like a classification problem. 2 simple metrics that we look at. The first is root mean squared error, and the second one is mean average error. And we can calculate those by taking, looking at the actual values from our comparison table. So those were in our population column against the values in our Arima Preds column and our RNN Preds columns. And if I run this particular piece of code, we're going to get this new table called metrics that'll populate over there in the bottom right of our environment. If we open this metrics table, we can see that it's just 3 columns with the root mean squared error for our Arima model, the root mean squared error for our neural net model, and similarly for mean average error. We get those values for each model. And we can bring this nice small little table into Power BI to visualize it in our model comparison here. So this should look pretty familiar. And when we're talking about error, we want the smallest error typically. So we note that in terms of mean average error, our Arima model had less error. It scored 132 versus 145 in our neural network, and it scored better in root mean squared error as well. So this is sort of like saying on average, our mean average error was in our Arima model, it was off, absolute value of 132 people each month basis, and our neural network was off absolute value, 145 people. So that's, your average error that the model had versus what actually happened. And root mean squared error is just a little more complicated form of pretty much the exact same thing, calculating the difference between what actually happened overall throughout the predictions versus what the model predicted. And we can plot all of these 2 models together against our actual values in a nice chart here. We have our black line representing our first model, that Arima model, and the red line representing our neural network model. And we can see the points at which each model was a little closer to the actuals versus the points at which each model was a little further away than the actuals. And taking just these error metrics at face value might not do us enough justice if we hadn't visualized this, because even though our Arima, our black line model, has lower error across those 2 metrics, we noticed that it took a couple months here. There was a big gap in our red line for our neural network, but once it hit April, it was hugging those actuals very, very close, and much closer for the most part than our Arima model did. So this might be a case where we want to say, hey, I know that our second model had more error, but it really seemed to catch up to the data, as time went on, a little bit better than our Arima model is. So let's pretend that we're going to use our neural network model to, now that we've tested it out and we've compared it, this is the model we want to go with, and this is the model we want to use to forecast for 2020, and that's what the governor asked us to do. Right now we're only doing that comparisons from what actually happened up through 2019. So we need to simulate the next 12 months and hand that to the governor and say, hey, these are our best guesses at what's going to happen in the next 12 months. So we can show how to do this in R. And what we're going to do is we're going to retrain our recurrent neural network model on all of the data. We're going to bind together, or essentially append our training data and our testing data together to create this new training data set, which is just very simply a table of all of the data from January 1st, 2008 to 10/1/2019. We're going to fit our recurrent neural network model to our new training data on the population variable. And then we're going to ask it to predict for the next 12 months. We're going to simulate using that model the next 12 months and add that to our backtest data frame. And we did this in a way that is going to be really nice once we bring it into Power BI to visualize. And I'll show you exactly why. So if we look at this backtest data frame that we originally created, we just kind of had the date and the actual population values, and then we left the last 12 months blank. But you'll see that we filled those with a new column called RNN Preds, or Recurrent Neural Network Predictions. And we'll be able to sort of pick up, when we do a line chart, sort of exactly where the actuals left off and where the predictions begin in Power BI by bringing this table into our last tab. So we can see all of our historical data here in the green line using that table that we just visualized in R that ends on today's date, because we're back in time on October 1st, 2019. And our black line is where our model picks up for the next 12 months that it's forecasting out. So we can see our predictions here starting on November and picking up right off of that line going through October 1st, 2020. We can visualize those predictions just in a table. We're just taking the values from this black line and sticking them in this table here over that. And we can hand this as a slide deck to the governor and say, hey, this is kind of what the trend line has looked so far in green. This is what we're predicting in black. And here's the actual predicted values over here on the right side of our table. Mission accomplished.
A quick question we got from Leo.
Yes.
Why use the actual population data set versus the difference in the 2 consecutive months, since that had the trend removed?
The neural network does not have the statistical assumption that the data needs to be stationary. That is why. As opposed to the Arima model does have a statistical assumption, a mathematical assumption baked into how the algorithm works, that the data has to be stationary. So very good question.
And honestly, I love the way this came out. I think it's a very clean visual. The way you kind of stacked it all up together and the change of the color, amazing.
Thank you so much. I had somebody on an ML project where I was building a model, and they, I think it was a forecasting model like this, and they asked me, they were a data engineer, and they asked me, what the output of that model was going to look like. What was the structure of the files that were going to come out. And I, there's this big misconception, and the fact is that it's just data under the hood. It can be rows in a CSV file. It can be rows in a database, anything like that. And understanding how to architect it together, and we can build really nice, clean visualizations like this, because at the end of the day, the output for many of these models is just going to be data. And however you choose to bring that to a decision maker, I think can make all the difference between getting the actual buy-in from the data science project or not getting it.
Totally. And I think that kind of leads into Leo's second question.
Sure.
I don't know if this is a question. I thought he said why, but it says way easier to do this in Power BI on the fly versus R. Would you agree to that? And then would you also agree maybe just using Power BI as a way to serve to business leaders a little bit more friendly than RStudio?
Yeah, I would. I would agree that I think Power BI is a great. I think you need to build. It doesn't necessarily have to be Power BI, but you need to build some GUI interface nowadays to be able to communicate the work that you're doing as a data scientist to non-technical folks that it's hopefully going to reach. I think that's a great maybe segue into, I guess, showing exactly my point. I think there's probably a lot of data scientists that'll roll their eyes as to me even using Power BI, but I get so many efficiency gains and so much buy-in from my projects by visualizing this data within Power BI, by visualizing my output within Power BI, because I can build a line chart literally this quick with 3 clicks of a button. If I want to build this line chart in R, it's going to look something like this, and I'm just going to do this for dramatic effect here. But I would have to first feed it maybe we'll just do our prison data set because that's simple. This is how long it's going to take me to do this.
Jeopardy music ensues.
Exactly. X equals date, Y equals population, and we'll do plus ggplot2 geom line. So this took me, and probably run into an error. Let's see. Run it again. Invalid graphic state. That's very strange. That's what I've been getting all night long. There we go. Got my line chart there. But I had to type 10 lines of code as opposed to 2 clicks that were really, really quick in Power BI. So definitely all sorts of cost benefit analysis that you can do. You know, the other big benefit of working within R or Python or a scripting language is version control, which kills me when the project really needs version control. But if you're in a project where you don't necessarily need that, you need to spin up something quick like I did here tonight, Power BI can be a phenomenal asset to you as a data scientist. So I can hop back in here. Let's see. So there's a couple gotchas, I guess, that I wanted to talk about as you start to maybe try combining R and Power BI together and working together with them. So beyond using R script as a data source in the Get Data menu in Power BI, like I did, I also want to let you know that you can apply an R or Python script to an existing table that you maybe imported from somewhere else in Power BI to transform the data that way. The way that you would go about doing that would be within the query editor, right? I have this data set, I've got my applied steps, and I want to run an R script against my data set, or I want to run a Python script against my data set because there's some functions there that DAX doesn't have or something like that to do some complicated calculations. You can absolutely do that, run into a lot of issues there because of type conversions, right? R and Python have specific types that your data has to be, that any data has to be. Like Python, you might hear floats and strings, things like that. In R, you might hear characters, numeric, doubles, factors, things that don't exist in Power BI. So there's a lot of guessing that goes on behind the scenes as data gets transferred back and forth from Power BI to R or Python, and it can lead you into a lot of problems that we've seen in the past. So it's something to be cautious about. It is doable, but I would recommend for the most part doing your ETL and your modeling in separate processes outside of Power BI for this reason. And also for the reason that was brought up, I think, in the comments, that you only really have local refresh of R script ETL in Power BI when you're using R as a data source. I don't think it's very easy or possible even to necessarily kind of run your R script or schedule refresh an R script visual or an R script data source up in the Power BI online service because R would need to be installed on that online service, right? You're using your local installation of R here in all the work that I'm doing because I'm just doing it on my desktop and pointing it to my local installation that we saw earlier, and that doesn't necessarily happen up in Power BI. And even if that did happen, there might not necessarily be a guarantee that the version running of R that's running, up in the cloud in the Power BI online service is, has fidelity to the version that you're running on your local machine, and you might get some issues there. So that's why we recommend trying to do most of the work separately. So let's see. Let's see. You can easily schedule, any ETL that you want to do or a model run in services like Databricks, Azure, AWS, Google Cloud, DigitalOcean. That's one that we really like. And then you can have Power BI pick up the output from those cloud databases where the output is stored. So then you would be able to schedule refresh in Power BI if Power BI has an easy connector to any of those services databases. And as we touched on before, when we built a histogram, the visualizations that you can output from R they're typically static, not interactive, which is a pretty striking deficiency. Maybe when you go to share your report with somebody who's used to interacting with all the visuals on Power BI, and they're trying to click on your ggplot that renders in Power BI, and nothing happens. There is the ability to create your own custom Power BI visual using R code that renders HTML. I'll show that in a second. But the GitHub page that I looked at today, that the Power BI forums reference as a guide on how to do this, that page is giving a 404 error. So not too much point at this point in time. I think investing your time in that, maybe the Microsoft folks will circle back to getting that documentation back out in the open. But for now, not looking super promising in the interactive R visualizations like I will show quickly here. We can write R code that generates tables like we did many times in our analysis. We can write R code that generates a visual like you just saw me do, a static visual. And we can also write R code. There are libraries that generate interactive visuals using libraries like Plotly. For those who aren't familiar, that's an open source library, works well with both Python and R for creating interactive dynamic visuals. So if I run this particular line of code here, I get a nice plot where I can actually hover over it, and dynamically it'll show me the values as I hover over my line chart. I can zoom in on particular portions of the chart, things like that. So this is an open source framework for essentially generating HTML. And it would be great if at some point in the future Power BI plays a little bit better with libraries like Plotly. But again, most of what you can accomplish is just kind of 6 in one, half dozen in the other, being able to do this in Power BI versus being able to do this in other places, as you guys all know well. So the latest news that I will share, I forgot that we're at a Power BI meetup, so let me change that first bullet point item really quickly. That's better.
There we go.
It's like
don't use the T word around here.
It's like Harry Potter and He Who Must Not Be Named, right?
Yeah.
So R has a phenomenal framework for building web applications and dashboards, and that framework is called Shiny. It's one of R's packages, libraries, and it essentially translates your R code into HTML and JavaScript, and allows you to build a back-end server and a front-end UI in a code-first way. And a big ask in a lot of the Power BI forums has been to integrate somehow Power BI with R Shiny. But this doesn't seem to be coming anytime soon. I haven't seen a lot of chatter in the forums lately. But Tableau recently did integrate with R Shiny. They worked together to release an R package, allowing users to use the power of R Shiny for data visualization, which, as a full-scale web app framework, Shiny allows you to do things like perform some action based upon an event, like a button click, or present, UI input controls like sliders, drop downs, text input boxes, or display Plotly HTML visualizations like I just built. And you can do so within your Tableau environment by essentially packaging your R Shiny code up as Tableau extensions. There's a little website here that kind of shows, the latest, and this is very, very new. This is within like the last week or so. So maybe, like you said, Microsoft will get fired up by its competition. And there's a quick video here. I'm not going to maybe take the time to show it, but if you just kind of search Shiny Tableau, that is the name of the R package. There's a lot of great documentation on what you can do, and maybe just a couple use cases for why it's necessarily even useful.
Well, hats off to Tableau for, kind of embracing that. You'd think Microsoft, for all the open source, that they speak to, hopefully it comes down the pipe. Maybe this is what kind of prods them, but it's great information to know, because I know there's a lot of shops out there that consequently sometimes run both Tableau and Power BI. So if you've got the R team, at least you got some, you can use this Shiny Tableau integration better than kind of what we're seeing on the Power BI side. But I feel like it's like PowerPoint. You kind of have to use kind of like a PowerPoint, where you're just doing a lot of your processing and a lot of the work just in R, and then, the ad hoc way of just getting it into the presentation layer.
Absolutely, and thinking really thoughtfully about, I think Ron and I were talking about this before, we kicked off tonight, thinking really thoughtfully about where the lines are between analytics and data science, and understanding that there is overlap, but getting that overlap right is really, really important. And architecting that correctly is non-trivial, difficult to do, and it's something that we do a lot of work on, trying to help folks out with. So those who get it right provide a lot of value.
For sure. Well, I do want to have everybody come off mute and give you a round of applause at this point. Like, thank you so much for getting into this topic that we've been working on.
Oh, thank you so much.
Love the reactions. Again, love the turnout for everybody that came on. Definitely want to give the floor for everybody to ask their questions. I see we may have a question from Jared Brown. I think he's just correcting the data.
I had to get the actuals.
There you go. That is hilarious. I see a question from Patrick. I don't even know how to say that. Esquisse package still be an option for quick EDA from within PBI desktop. Words I don't even know.
Yes, so there's a great package which kind of serves as like an add-in within RStudio when you run this package, and it does allow you to, it just pops up a GUI right in front of you and allows you to have, kind of sort of a Tableau or Power BI environment where you can pick your chart type, you can pick your variable from your table that you want to use, and you can build quickly different types of charts that, right in the kind of this nice GUI interface. So that is definitely an option for quick EDA. I don't believe that it is at all an option within Power BI desktop. I'm not sure how that would work, and I haven't seen any ways that would work, unfortunately, because I don't think Power BI would be able to launch that GUI for you.
We get another one. When writing the script to create new data sets like the comparison table, do you write it in RStudio or in Power BI interface?
Yeah, so tonight what I did was I wrote it, I just kind of wrote it first in RStudio to make sure that it worked. But I copied and pasted all my code once it did work over into Power BI. And I can, maybe just double down on how I did that. So I literally just went into home, new source. Maybe I'll actually just do it now. R script, right? And then I'm prompted with kind of this blank box where I need to go grab my R code. Let me end my slideshow here. And I just Control A, Control C, copied all of my code. Go back into Power BI. Why is that not working? I can't click it. I don't know what's going on. I apologize. But I go back into Power BI and I paste it right into that prompt.
If you go Alt-Tab, you can do that.
Oh, thank you.
Slash thing, and
that's a classic. Yes. Thank you so much.
Classic.
And I just Control V and paste all of that code in here. And when I do that, I should have a data source pop up over here on a new query pop over here on the left.
So do you edit the code at all in Power BI, or you only edit in R?
So for the most part, I'm writing the code and editing the code in R. And then once I know that it works, I can just copy and paste that code over into Power BI, because I know that code runs successfully, and it's going to create these tables that I can pick from. It's going to render these tables that I can pick from in Power BI.
So you were talking about how you don't really want to use this when it's Power BI in the cloud, because you would need the R installed, that same version that you use on your desktop. And so have you seen like a machine learning, forecasting algorithm, predictive algorithm deployed, like in Power BI in the cloud, or?
So we've seen the results, the forecasted values of a predictive model get picked up in Power BI to be able to display on a daily basis to end users. There's a great project that we worked on with Talon and with Jared, who's the Microsoft partner that we talked about earlier, where we were forecasting like water quality, the pH of water, the temperature of water for a major municipality for the next 24 hours. And right, that was a model that was doing that hard work in Databricks. It was just outputting the values for the next 24 hours that it predicted. And we picked those values up in Power BI. And that was the front end where people logged into to see what tomorrow's forecasted water quality data was going to be.
Cool. So it was built in the cloud through Databricks, and then Power BI connecting through into Databricks.
Into the output.
Did you have to store the data in a blob storage from Databricks and then connect Power BI into blob?
That's typically the way that we do it. Blob storage, helps for a lot of reasons in terms of sort of version controlling the data that comes out on a daily basis to make sure, maybe we're writing a new folder for each day that contains a new flat data set. CSVs, it really depends on the project. For this particular project, the output was only 24 rows of data. It was just one data point for each hour. For other projects, we're doing big batch scoring, thousands or millions of predictions. And then for many other projects, an API makes more sense because you want to host this API somewhere that people can ping at any time and just get a single prediction back from that API. You can think about how it works when people log on to Amazon. There's an API that quickly grabs all your data that's cached in your browser and shows you the recommendations that it thinks are going to be best for you. It's not doing any batch scoring or anything like that. So it really depends on your use case and on your problem that you're trying to solve and accomplish and work towards.
It's a great explanation, Michael. Thank you.
There's a lot of jargon and a lot of marketing and sales decks that I don't know, scare people the wrong way or make things sound like it really isn't in this space, unfortunately. So I do a lot of work just kind of smoothing out some of the BS.
Absolutely. I think there's a lot of architecture out there and terms everybody throws around. I think the ideas around AI and ML sometimes get a little amorphous too, but when you can clearly explain it, clearly see the use case, it just kind of makes things come into view a little bit better.
And I'm Italian, so I can point to the API going up and down. And
you got to do this. Yeah.
Exactly.
The scoring model is beautiful. Any other questions? Well, we got Michael on the horn.
Thank you for the questions.
Perfecto, love it. Feel free to come off mute or type your question. Speak now, forever hold your peace.
This is where everything is, the PBIX file, the R scripts. I got a little README there in the bottom that you can take a look at if you're interested in the materials.
This is great. Michael, can we put this in the recording? Should I have this link in the recording?
Sure.
We're going to publish?
Yeah, it's public. It's a public repository. Sure.
I'm just going to steal that link real quick. Awesome. Well, let's give you another round of applause for sticking on late. I know you're in the East Cost time. It's 9:30, and just thank you for giving us your time.